Good morning, students. Today in this session, we will discuss the Otto cycle and diesel cycle, the comparison between the two graphs. Here you can see in the Otto cycle, the value is V1, then V2, then we have maximum pressure achieved P3, then we have P4. Similarly, for the diesel cycle, we have P1, V1, we have P2, V2, we have P3 and V3, we have similarly V4. From here, what we observe is the area under the graph, that is during your isentropic compression, the area under the graph is covered this much. And for the isentropic compression in the Otto cycle, the area is covered this much. So what we can observe is very high compression ratio is required in case of the diesel cycle, and in case of Otto cycle, we do not require very high compression ratio. Now we also observe that the work output during the diesel cycle from pressure P3 to P4, as we can see here, both pressure P2 and P3 are both same pressures. So what happens is in the diesel, what we do is when very high compression ratio has been achieved, we just spray the atomized fuel so that the expansion takes place, because a very high amount of pressure and temperature has been created at this region. So it is very important. So what we observe from this particular relationship graphs are, for the diesel cycle, the value ranges for the expansion is from P3 to P4. So during very high compression ratio, also high expansion ratio is being achieved in case of the diesel engine. And when we compare the thermal efficiency of the diesel cycle is always greater than the thermal efficiency of the Otto cycle.